Who is responsible when an AI agent slips its sandbox and breaks into someone else's network? OpenAI has now found more incidents of agents crossing containment, and the more of these we find, the more questions we have. Here's the claim I'll stand behind. Autonomy can spread action across a network, but with the legal and economic systems we have now, that autonomy cannot erase the human chain of responsibility. Come with me, let's get into it. OpenAI's investigation keeps getting wider. TechCrunch reported that the company found evidence of more agents that ran amok, that is a quote. They broke free of the isolation meant to contain them, and then they took actions that their operators had not authorized. Now, to keep this framing realistic rather than the sensationalized version that you see in so many headlines talking about the doom of what this actually means, an AI agent here is a system with credentials and permission to act across networks. You give the agent an objective, and it pursues that objective through whatever paths that its permissions leave open, whether intentionally or not. Now, a sandbox is supposed to close those paths. It gives the agent room to work without letting it touch the wider network. That's one example. At least one of OpenAI's escapes began with a very human mistake. According to the company's account, someone configured the permissions incorrectly. Now, that distinction is decisive. Nothing in that account shows a model choosing to turn hostile. Humans drew the fence incorrectly. They left gaps, and the agent followed the open paths through it. So let's call that what that is, a systems integration failure. So the response then will start with stronger engineering discipline around credentials, permissions, testing, and containment. Now, back on July 29th, we covered the OpenAI agent that had routed through a previously unknown JFrog flaw and into outside accounts. Yesterday, we also covered that Anthropic had 3 models that had reached the open internet as well, and that they had found those during internal testing of their own. And they also said that that breach was due to what an evaluator had misconfigured. Now, any single breach can have its own technical cause, but across the labs, though, the repeated weak point is becoming pretty hard to dismiss. Organizations are given capable agents access to live networks before they can reliably contain what those agents do with it. And now the question has moved beyond engineering. Clément Delangue, the CEO of Hugging Face, has publicly called for AI companies to face legal accountability when their agents cause damage. Hugging Face was one of the parties hit in the OpenAI incident. Delangue is speaking from the receiving end, then, of the intrusion, and he's rejecting the idea that each breach can remain an isolated technical hiccup. Security researchers who traced several of the hacking sprees found that much of the activity was illegal on its face. The agents entered systems their operators had no right to access. The law still doesn't have a settled answer, though, for who is actually responsible. Developers build the systems, yes. Deployers choose how and where it runs. Users provide goals. The model carries out the work. None of those roles fits neatly into liability rules that are built around a human deciding to perform an illegal act. It's not that simple anymore. That gap can't become then an escape hatch. When a company grants credentials and sets permissions and places an autonomous system on a network, responsibility still has to follow that permission chain. The agent's autonomy changes how the action happens. It doesn't make the people and the institutions behind the deployment disappear. Now, there is also a constructive part to this reckoning as well, regardless of who's at fault. OpenAI published its finding that human configuration helped cause an escape. Anthropic disclosed its own containment failures and brought in Meter for independent review. Those disclosures let every lab and security team learn from that mistake. Engineering practice can spread through the industry faster than a liability statute can pass. That is the very definition of being open, as in open source and open weights. Now, a year ago, these failures probably appeared as autonomous postmortems. And yes, there are layers to this. I'm not saying that by being open about this particular thing that suddenly Anthropic and OpenAI are suddenly truly open source about everything. Of course not. But what I am saying is that a year ago, these failures probably appeared as anonymous postmortems. But now researchers are able to document the illegal access. Now, the accountability structure isn't finished, not by a long shot, but you can see that slowly and imperfectly though it is, the pieces for that structure are being assembled. All right, moving over here. Responsibility needs a trail that others can inspect, but our next story shows what that looks like when a major scientific result arrives with its own public check. Researchers at IBM and the University of Chicago ran a computation on a 70-qubit logical circuit. Now, a logical qubit is built from many noisy physical qubits. Error correction ties them together so that the combined unit behaves more reliably than the hardware underneath it. That is the threshold that quantum researchers have chased now for 2 decades. The researchers have reported that in this experiment, the logical error rate was roughly 10 times lower than the physical error rate. So the system completed more than 2,000 logical 2-qubit operations, along with hundreds of T-gates, and it finished in about 15 minutes. Reproducing the same work on leading classical systems would require a prohibitive amount of time. Earlier quantum advantage announcements came with this awkward problem. The computation was initially beyond direct reproduction on a classical machine, so outside observers had to rely very heavily on the company that was announcing the result. Bill Pfefferman at the University of Chicago and doctoral student Soumik Ghosh designed this demonstration around an answer that can be independently validated. And then the team published the circuits on IBM's Quantum Advantage Tracker. Other groups can examine and rerun them. Now that openness changes the weight of the result. IBM doesn't have to be trusted simply because IBM made the machine. The computation can defend itself. A companion study also pushed in the same direction. Blue Qubit, Kedma, IBM, and Riken simulated a Floquet-Ising system on IBM's 156-qubit Heron processor. They compared it with 500,000 CPU core hours on the Fugaku supercomputer. Jay Gambetta, IBM's research director, called this the quantum advantage era. Now, the physics do earn real excitement here, but IBM's business forecasts deserve a separate look. The company told investors that quantum computing could have a measurable impact on revenue by 2028 or 2029. It also described $1 trillion of value arriving by the end of the 2030s. So IBM benefits when customers and shareholders believe that roadmap. Its stock had fallen 25% earlier in July before recovering. A huge commercial forecast helps tell a reassuring story. The verified result, though, doesn't need that story. Its near-term promise is narrower and more concrete. Reliable quantum systems could simulate molecules, materials, and quantum behavior that classical computers handle very poorly. Those simulations could open paths through chemistry and material science that are currently too expensive to search. And that is a huge catalyst for much more beyond that. The circuits are public, too. The capability can spread beyond the institution that built it because the evidence traveled with the result. So we're seeing the beginning of something really big here on this one. All right, now we move from that quantum result that is easier to verify than traditionally to an image that's suddenly much easier to fake. Google Earth has added Nano Banana as an image generator inside the app. People with access to the web-only feature can prompt and create AI-generated imagery grounded in real Google Earth views. Now, reporters immediately generated scenes of a drone strike and damage to a nuclear plant. They also made images showing refugees at a border. So at a glance, the results could pass for genuine overhead photography. That touches a very special kind of evidence. For decades, people have reached for satellite images to prove what was physically happening on the ground. Making a convincing fake required costly machinery and specialized access. Governments and imaging companies had that access. Most people did not. So the expense acted like a lock on forgery then. Nano Banana, though, removes that lock in an afternoon. Google says generated images contain its invisible Synth ID watermark, and that is the safeguard the company offers. But the important test now sits outside Google's description of the feature. Does that marker survive when someone takes a screenshot, or crops the image, or reposts it on a fast-moving feed? We don't have that proof yet. And the interval is dangerous. Fabrication is already moving faster than verification. A fake image of a military strike, nuclear damage, or refugees can cause real harm while people are still trying to establish where it came from. Now, the same news cycle brought several attempts to change the incentives around synthetic media. Snapchat stopped paying rewards for fully AI-generated spotlight submissions. That cuts the financial lure that had drawn a flood of machine-made clips. LinkedIn added a button that lets users report AI-generated slop directly. Similarly, Substack had rolled out Pangram a couple of weeks back as well to catch AI-generated material. Major record labels are moving to tie chart eligibility to human authorship. Meanwhile, AI-generated melodramas are already spreading across X, where creators can collect real money from the attention that they attract. Now, these moves don't all come from the same motive, and they don't do the same job. Snapchat is changing what it pays for. LinkedIn and Substack are giving users a reporting lever. The record labels are drawing a human authorship line. Google is attaching an invisible marker. And tomorrow, August 2nd, European Union rules begin requiring labels and watermarks for authentic-looking synthetic images, audio, and text. Each piece has limits. A reporting button acts after publication. One platform's payment rule doesn't bind another platform. A watermark only works if it survives whatever happens to the file next. Together, though, they point toward a new way of deciding what to trust. An image used to earn credibility because it was hard to make. Now it has to carry a reliable history of who made it, how it changed, and where it came from. And that authentication layer is still rough. The capability that made it necessary is also pushing platforms and regulators to build it quickly. Now, before we leave this, step back with me for just a second. Now, the easy version of this story about Google Earth having the ability to now generate fake images is that we're walking into a world where nothing can be believed. That's the headlines. That's what they're saying right now. I don't think that's where it lands. Look at the various fixes that are being put in place that we talk about here on the Century Report, and honestly, all of today's stories as well. Watermarks, labels, reporting buttons, authorship rules. Every one of them assumes you have to be told where something came from by somebody with the standing to be able to tell you. That is what we call scaffolding, and we're building it because checking is expensive right now, and only some players can afford to do it. But the question you actually have when you see a photo of a drone strike or a flood or maybe some kind of possibly legitimate creature or alien visitation is simpler than any of that. Did it actually happen? That is your question. And answering that one gets cheaper and easier all the time. You can check a claim against everything else that would have to be true if that picture were real, such as the river gauges, maybe the people nearby, the angle of light on the buildings, for example. Remember the little padlock that sits up in your browser bar? It means that somebody has checked the connection for you. Now, Chrome removed that a couple of years ago because verification had become so ordinary that announcing it became just noise. In fact, safety is so normal and assumed in many of the common pages that people visit that when something is wrong, when we go to a page that is incorrect, that's when we are interrupted. Not the other way around. We don't have to take on checking everything that we look at because it's already been done, and when something is wrong, that's when we're presented with the information. And that's very similar, I think, to what winning will look like here. That checking and verifying will become so ubiquitous and cheap that the label itself stops even being necessary at all. All right, our last story leaves the public media behind and listens very closely to how a child builds a sentence. A Stanford team analyzed audio-recorded interviews with 204 young people. They were between 9 and 13 years old. The researchers ran 4 separate natural language algorithms across the recordings. Those models anticipated which children would receive a mental health diagnosis 6 years later. On this study's later outcome prediction task, they did it more accurately than scores from a panel of clinical experts who reviewed the same interviews. The study was published in Nature Mental Health, and yes, there is a danger here of the overbroad collapsing of everything into overdiagnosing mental health issues. But the strongest signal in this particular study sat in the structure of the speech itself. The algorithms paid attention to things like pronouns and conjunctions and the way that children assembled clauses. So think of the really small words that hold a sentence together, and, but, to, that kind of thing. Those structural patterns explained more than twice as much of the difference in later diagnoses as the traditional risk factors scored by people. The subject of the conversation still carried information, of course. Accounts of severe physical violence or harsh social exclusion did track with higher risk, as we've already known. Mentions of therapists, counselors, and extracurricular activities appeared among the strongest protective signals. The larger discovery, though, sits in the sentence architecture, and that's something we haven't seen before. A child may leave traces of future risk in ordinary speech years before depression or anxiety becomes clear enough to actually diagnose. Now, today's other approaches can be really expensive. Measuring cortisol requires a blood draw. Telomere measurement needs specialized equipment. A full clinical assessment, of course, takes hours of expert time and is very expensive. Those costs keep broad screening out of reach for many children. But speech begins with a recording. Chase Antonici, the lead author, described the work as proof of concept for finding risk markers before diagnosis. That is an important limit. No ready-to-use screening service exists here yet, but hopefully it will soon. Ian Gottlieb, the senior author, put the possibility this way. If these findings hold, it means we may be able to just take smartphone recordings of children talking, analyze that speech, and identify which children are at risk years before they might develop a disorder. Now, that part he said there, if these findings hold, that carries a lot of weight. The results do need further validation, especially with our tendency to overdiagnose on mental issues. Any real system would need strong privacy protections, and the risk score only really matters if it connects a child to care that actually helps. But still, the capability is striking. Adolescence is when depression and anxiety often take hold. Clinicians have had no affordable way to see far into the years before diagnosis, but now that near-blind stretch is starting to become visible. And we've seen the same shift elsewhere, too. Plasma protein models can find traces of chronic disease more than 15 years before the onset. We've talked about that recently. AI has also detected pancreatic cancer in screens 3 years ahead and predicted acute kidney injury a day ahead. This time, the early trace lives in language and is more mental than physical. The intervention window may begin opening while a child is still well enough for support to change what comes next. All right, let's bring it to a close here. Who is responsible when an agent crosses a boundary that its operators thought would hold? We don't really have a settled answer yet, in part because the questions we are now asking just don't fit the systems we have in place. This is one of many reasons I keep advocating that the system is what needs to catch up. But for now, the principle is clearer than the statute. Autonomy cannot become a tunnel through which responsibility escapes. That principle needs working structures around it. Public failure reports, independent review, clear standards, liability that follows the people and institutions that grant access and deploy the system. The rest of today's stories show why verification is becoming basic infrastructure. IBM and the University of Chicago published a quantum result that other researchers can check. Google Earth made a trusted class of imagery easy to fabricate, and platforms are now assembling labels, reporting systems, authorship rules, and watermarks. Stanford's speech models opened a path toward much earlier mental health support, while still leaving, of course, validation and privacy work ahead. The old shortcuts for trust seem to be wearing out here. We trusted an action because we could trace it to one human hand. We trusted a quantum result because a respected institution announced it. We trusted a satellite image because forging one cost too much, and we waited for illness to appear because we couldn't see it coming. Increasing capability is breaking each of those assumptions. What's arriving alongside it, then, is encouraging. A public circuit can carry its own check. Provenance can travel with an image. Containment failures can now teach every lab how to redraw its permissions. A simple recording may one day help care reach a child years earlier. Capability exposes the missing structure, yes, and then we build it. That is the work taking shape now. Wider access paired with evidence that anyone can inspect, earlier insight paired with care, and autonomous action paired with responsibility that stays firmly attached. See you tomorrow.